What if I told you that every computer ever built, from the Apollo guidance computer to the GPU running GPT, can be constructed from a single type of component? Meet the NAND gate. It takes two inputs, A and B, and produces one output. Let's see what it does. When both inputs are 0, output is 1. When A is 0 and B is 1, output is 1. When A is 1 and B is 0, output is 1. But when both inputs are 1, output is 0. NAND means not AND. It's an AND gate followed by a NOT. It inverts whatever AND would give you. And here's the thing that makes NAND special. It's universal. We can build any logic gate from just NANDs. Let's start simple. Can we build a NOT gate using only NAND? Here's the trick. What if we connect both inputs of the NAND to the same wire? When our input is 0, both NAND inputs are 0. And remember, NAND only outputs 0 when both inputs are 1, so it outputs 1. When our input is 1, both NAND inputs are 1. That's the special case. NAND outputs 0. We just built NOT. One gate down. Let's build the AND gate next. AND is trickier. But remember, NAND is literally not AND. So if NAND gives us not AND and we invert that result with a NOT gate, we get AND. The first NAND does its normal thing, A NAND B. Then we feed that output into our NOT gate, which is just another NAND with its inputs tied together. Two NANDs in series. The second one inverts the first. NOT of not AND equals AND. Let's verify. 0 and 0 gives 0. 0 and 1 gives 0. 1 and 0 gives 0. 1 and 1 gives 1. Perfect. OR is where it gets clever. We need some mathematical magic called De Morgan's theorem. De Morgan's theorem states that not of A and B equals not A or not B. It's one of those beautiful symmetries in logic. So if we rearrange that, A or B equals not of not A and not B, which means invert both inputs with not dates, feed them into a NAND, and we get OR. So we need 3 NANDs total, 2 as inverters on the inputs, 1 to NAND the inverted values together. Let's check one example. If A is 1 and B is 0, not A is 0, not B is 1, NAND of 0 and 1 is 1, and 1 or 0 should be 1. It works. From one humble NAND gate, we built the NOT gate, the AND gate, and the OR gate. These 3 gates are the building blocks of everything in computing. Every processor, every memory chip, every digital circuit. Next time, we'll use these gates to build something that can actually add numbers. See you then.